Hello everyone. This video is about the interval frequency table. Okay, before we talk about interval frequency table, let's talk about um, the type of data that you might encounter, population data or sample data. So let's talk about population data. In the realm of statistics, a population refers to the entire set of items or individuals under consideration. It includes all data points relevant to a particular study. So when we talk about these interval frequency tables, it's possible that it will include all the possible data points in the study. On the other hand, a sample is a subset of this population, a smaller group chosen to represent the larger whole. The idea behind taking a sample is that by examining a smaller, manageable portion, we can make inferences or predictions about the entire population. So sometimes it's more convenient to get a random small sample compared to the whole population. And with this sample, you can infer and you can predict how the whole entire population reacts. A lot of times it's more about money. It's easier to get a smaller sample than a large sample, or time. Sometimes even when you do get the whole entire population, right, you measure whatever you're doing, that by the time you finish measuring, things have already changed, possibly. One example is like fruit. Maybe you can weigh all the fruit, right, that you're trucking in, but by the time you arrive, let's say to the supermarket, most likely that fruit has changed in weight or whatever it is that you're measuring. Data samples can often be vast and challenging to analyze directly. To make sense of such an extensive data set, we need to structure, condense, and present the data set in a clear and significant way. So a lot of times when you have a bunch of numbers in a list, it would be nice to organize them in some way. And this way we're going to be understanding how to do it in a interval frequency table. This organization can be numerical, often laid out in tables or visuals. It can be also done in formulas too, as seen in graphs, but the end goal is not just to produce a table or graph it. It is to analyze the information and decipher its meaning. A table doesn't really tell you anything until you start describing what you organized, or a graph too. When you see a graph, it's best to tell the audience, like, this is what we're seeing and this is what it means, to analyze the information and decipher its meaning. Okay, so interval frequency table. It's a table that simplifies the organization and interpretation of large data sets or samples. It presents the frequency distribution of continuous data divided into intervals called bins. You could, technically you could have discrete data, but the interval frequency tables usually have continuous data, meaning it has decimals or fractions. Bins are intervals of equal width that cover all the values that are observed. The frequency of a bin is the number of times it occurs in the data set. So here is an example of a interval frequency table. You can see that it has these bins that are spaced evenly. Okay. Looks like the data set starts closely to 40 and it ends not at 75, and we'll talk about why it doesn't. So these are called bins, right? And bins right here. Bins in frequency tables are mathematical intervals. and we'll talk about those intervals. And then an interval is a range of numbers. Again, we're going to look at that. And then this column over here is the frequency. How many numbers that are between 45 up to, what data values are between 40 through very close to 45. We'll have 3 of them. And we'll talk about why 45 is not included. It's really based on the interval terminology that you might have learned in grade school. So both parentheses and square brackets are used to denote an interval. And the notation bracket A, comma C, parentheses is used to indicate the interval from A to C, that it's inclusive in A, but not in C. What does that mean? Well, it means that when you have a bracket, it means you include that value. When you put a parentheses, it means you don't include that value in this bin. So here, excuse me, you have 40, 41, 42, 43, 44, and all the continuous values that you want, right? 43.333422121, whatever, right? All those values, they're continuous. 44, all the way up to 44.9999999999999, right? But not 45. So if in your data set, if you have a value of 44.942, it would go in this bin. But the moment you have a value of 45.00, it would go into the next bin. Okay? That's what the notation is telling you to do. All right. So let me erase these very quickly. Now, the width of the bin is also important too. Some teachers will give you the width of the bin. Sometimes you need to determine it. The width of the bin here is 5. Okay? So how is that? Well, you got 40, 41, 42, 43, 44, but not 45. So the the bin width is 1, 2, 3, 4, 5. Okay? Even though we don't count 45. So the width of this bin, or the width that you can put numbers in this bin, is 5. Okay? You can see over here, 40 through 45. You include 40, but not 45. And then what happens is that if you do have a 45, it'll go in here. Same thing over here. 45 is included, but not 50. Where does 50 go? In here, in the next bin. And so here in this particular, and the last, I guess, the last bin, right? You can see that you include 70, 71, 72, 73, 74, and all of its continuous values. But you won't include 75. So in this particular data set, you know there is no 75 value. There might be a 74.994 value, but you wouldn't know in this table without looking at the data. And then you can see that you could start at 40. It doesn't necessarily mean that these bins don't tell you, well, there is a value that is 40, or a value that's 45, or a value that's 56 or something. You don't know. They're just bins that collect these numbers. Okay. So let's look at some examples. You want to know how much cash students carry. You randomly choose 20 students and ask how much cash they carry. Below are the results. Create an interval frequency table of bin size 5. So you randomly choose 20 students, and here are the values. Some students had $0, $10, $5, $14.99, and so forth. So they say to make a frequency table of bin size interval frequency table of bin size 5. So in this case, I think I'm going to start with 0. Now, you're going to have two columns, the cache, which is the bins. What are you studying, cache? And then the frequency. How many times in that bin do you have those values? So because it's bin size 5, I go from 0 to 5, right? 0, 1, 2, 3, 4, but not 5, right? So 1, 2, 3, 4, 5. There's 5 values in here, right? That will give me the bin size of 5, even though I'm not using the number 5. Remember, this goes up to 4.99999999999, very close to 5, but not quite. Okay, might look a little bit weird. And why do we do this? Because if we just said 0, 5, 5, 10, 10, 15, then it would be like, well, do we put the 5 in this bin or in this bin? Right? It's very confusing. So that's why we put the brackets and parentheses, so that we can say, well, you don't put the 5 in here, but you put it in here in the second one. That's the whole idea. Okay. Okay. And then 5 and 10, 10 and 15, 15 to 20. The y stop at 20. Well, if you look at the data set, there isn't any values that are 20. Then you take each data point and then you say, which bin does it go in? So 0 goes into the first bin. $1.25, first bin. 75 cents, first bin. $10, third bin. Excuse me. $5 goes in the second bin. $14.99 goes in the third bin. $1.67, first bin. 1 penny, first bin. Now, you can see that I crossed out. I have 4 and then I crossed it out to represent 5. Do you have to do that? No, but it's easier to read when you have those line strike. What else? $19.79, last one. $10.01, third one, right? $3.44 is the first bin. $6, second bin. $8.10 is on the second bin. $5.09 on the second bin. $7.99 second bin. $1.63 first bin. $0 first bin. $5.60 second bin. $19.98 last bin. $9.99 is on the second bin. Now, here you can see a frequency count already emerging. And I guess what you could do is you can think of this as a graph almost. You see that? You can see that there's a lot more bin 1, then bin 2, then bin 3, and then bin 4. Looks like there seems to be a pattern emerging. And of course, we use this table to do histograms, which is a video that you can watch. Okay, so some questions you can answer now. For example, how many students have less than $5? Yes, you're right. 8 students right here. Right? You can see that there's 8 because here this tells me it's less than $5. Okay. How many students have 10 or more dollars? 10 or more. Well, we know that 10 doesn't exist here, and they want more than 10, right? 10 or more. Okay. So 10 or more. So that means we have to count these. And How many is that? 5. What's next? What fraction of students have less than 10? Fraction. So a fraction just means you need a denominator and a numerator, right? Numerator, denominator. The denominator says, how many do you have all here? Well, we already know that. There's 20 of them. And now we need a fraction of 20. We need to take a piece of 20. What piece is that? Well, less than 10. Less than 10. So less than 10. So this is where 10 lives. So it's less than 10. We need these right here. We need to count those. And so it's going to be 20. And then when we count the rest, it's 15. Right? Let me get rid of this. 15. There's 15 in here. So that's what? 8. Well, here, 10 and 5, right? Oh, that was easier. 15. And 15 over 20. Then we need to reduce. 3 divided by 4 times 100 is 75% of students. See that? So these are the questions that you can ask. So let's think about this. You can have a population or a sample in these interval frequency tables, right? A table, something visual helps in organizing the information, but it doesn't really give you the meaning. And then there's these interval terminologies that you need to think about, right? Why does it have a bracket? Why does it have a parentheses, right? Well, if you have a number, again, 50 through 55, 50 means you include 50, but here, this 55 you don't. And why would you want to do that? Because if you just wrote 50, 55 for a bin, and then 55 to 60, right? 55 goes where? Does it go to this bin or that bin? You have to give it some clues to the person that's reading this table. Okay. And why do we have these type of tables? So we can do histograms. Well, that's one of the reasons why. And then you can have a data set, and then they might ask you to put it in a table. Sometimes they'll tell you the bin size. Sometimes they don't. If you do this in a computer, the computer will do it for you, like Excel or something. Well, no, not really Excel. But thing is, if you as a student choose a bin size different from another student, then these frequencies will be different. So sometimes consistency is best. And then you can answer some basic questions on the table. All right, good luck with this. Share this video with others, please. There's a bunch of other videos on this site. I hope you have a great day, and I'll see you later. Bye-bye.